All right, Pascal's triangle. Given an integer num rows, return the first num rows of Pascal's triangle. In Pascal's triangle, each number is the sum of the two numbers directly above it as shown. Oh God. So number of rows, they give us a number of rows, 5. Okay, I see. So it always starts with 1. And so the output, 1, 2, 3, 4, 5, and 1 equals 1. Each number is the sum of two numbers directly above it. So, okay, so it'll always be 1, 1, 1, it looks like. And then 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4. What happens up here? 1 plus 1 is 2. Okay, so 1's always in the start and also at the end. Okay. Give us examples. How nice of them. Let's see. So, I mean, it looks like you'll always have this one and this one. Also just all of these. It's interesting. How do I go about doing this? So we definitely need to loop through this many times. And we could keep track of the triangle in, let's see, how would we keep track of it? So if it was just an array, so we'd iterate. No. So if it's just an array, we could create empty arrays. So we could loop through 5 times and create an empty array, and then add 1 to the beginning and end. So we'll have one of these, and then on the second iteration we add 2, on the third iteration we add 3, but only at the end. Only at the ends. Okay, so let's say we have that. Then what? Then we need to iterate through again. And every time we iterate through one, we have to use the previous's locations. So this is index 1. So I would need to add from index 0 and index 1 from the previous. Let's see if that logic works here. So here's index 1, so I need to add from here and here. Here and here, right? Here's index 2, so I need to add from index 1 and index 2. So the algorithm there looks like it will be the index minus 1 plus the index. That will get us these values here. That's interesting. So there's that. Still kind of stuck on how we're going to keep track of this. I guess we could have a map. We could think of a map. So at index 0, we have one of these. Index 1, we have one of these. Index 2 will have one of these, right? So the length of the array is going to be I plus 1. So let's say we're on the third, or let's say we're on the second, and we're creating this array. As we get to an index that's not the beginning or the end, then I'll point to I minus ones array and get the index minus one, which is the 0th index, and the index that we're currently at. Okay. So how does that work for this one? We don't need to do it because there's no x. I think that's making a little bit more sense. So the plan is going to be to create a object that keeps track of the index at which we'll iterate through with this number, and then we'll create I plus one amount of arrays or length of array, making sure to insert one into the beginning and the end. And then we'll do the same thing moving forward. And let's say we get to an array where it's not the beginning or the end. We need to calculate this based on the previous array that we just did. Probably don't need a map. We could just keep it an array because the indexes are like our keys. And yeah, let me just think about this for a couple seconds to see if there's anything that I'm missing. Yeah, I don't see anything like blaring or obvious. I do see a pattern where like half of this array is essentially the same thing, just reverse. Don't know if that will be helpful at all. That might just make things more complicated, to be honest, in our algorithm. But yeah, I think I'm okay with at least attempting that. So let's get into our code. Test case. Okay. So generate. So they're giving us a number of rows. Let's iterate through that number. So we'll start with I. And we'll say is I less than nums row, I plus plus. And we're gonna need a store or an array to store these. So so the length of the new array, right, is going to be I plus one length. I think you can do something like this. And that will give you, we don't need to initialize it, right? We need to create another loop. Which will iterate through I, right? We need to do I plus one in this case. And we'll essentially say if j is 0, or J is I, or J is the length of the array, which will be I. Yeah. So if any of those, then we're going to assign J to 1. Else, we need to calculate. Oh, my brother came. 1 second. Okay, we're back. Let's see. Yeah, so if we're in the beginning or at the end, then we're going to insert 1. Else, we're going to need the previous array or the previous row. So in this case, result of I minus 1, that'll return us an array. All right, so we'll call that previous row. So with that, we need to calculate what previous row of J minus 1 plus previous row of J. And once we do that, we will push this new array. I think that's right. What are we returning? We're returning the result. Okay. I feel pretty good about that. I think that is how we described it earlier. Let's just run it. Let's see. Oh my God. Oh my God. Let's submit it. Oh my, are you guys seeing this? 27%. That's not bad. At least we solved it, and we still had 2 minutes to go. With that 2 minutes, let's see if I can think of a better solution. Let's see. So as I said earlier, when we're in that bottom of that triangle, I'm just gonna make up some numbers, but like, ooh, 6, 8. I just made this up. But like at a certain point, there's an inflection point, and then everything before it is the same thing after it, except reverse. Jeez, I cannot draw today. So I wonder when that inflection point is. I guess I could just calculate the mid with the I that I have. So I is the length of, I plus 1 is going to be the length of my array. So if I do I plus 1 divided by 2 and floor that, that would be my inflection point. I guess no, I wouldn't floor it. If it's a whole number, that would be my inflection point. If it's not, it just brings a little layer of complexity. And, you know, copying this, reversing it, and appending it, I don't think it's going to be faster, right? Yeah. Yeah, that's all I got. Thank you. Thank you. Oh, I got 9 more seconds. Fuck it.